Hi, everyone. Welcome to our today's webinar hosted by Softermii, Machine Learning Operations in Healthcare. We will be getting started in just a few moments as people are still joining. In the meantime, feel free to say hi in the chat and let us know where you are joining in from. We always love the diversity, to know the diversity of our tech community. As you can see, we have Spain, Madrid here. Nice to hear from you. Thank you. Anyone else? Thank you. I see UK, London, Abuja. Nice to see you guys here. Guess we'll wait just for one more minute till few more people join in. Then we'll get started. So let me quickly introduce our team. Today, our speakers, Nazari here. I am a senior partner, growth partner at Softermii, and Roman is our lead DevOps engineer. He's our main speaker today. We're excited to have you join us as we explore how machine learning operations is transforming the healthcare industry, how it's helping teams to optimize machine learning workflows, protect sensitive data of the patients, as well as reduce operational costs without slowing down the innovation. From our side, we'll do our best to make this webinar valuable for you. And I guess we are ready to move forward. We are ready to start it up. Roman, please go ahead.
So, hello everyone.
Yep, just one more second. What we are aiming here is our agenda for today's meeting. We're going to talk about the machine learning operations, its core principles, as well as we will talk about the key cost-cutting strategies across the machine learning lifecycle. We will walk you through the practical roadmap of the implementation in terms of 18 months. Also, we will pick up the really important topic nowadays. We'll talk about the security and data protection. Moving forward, we will talk about the real world case with our experience of working with previous project, and some final takeaways and insights will be summarized. Then following up, we would like to hear your feedback. How did you like it? And as well as we'll have the Q&A session where you'll be able to ask any questions that may arise during our webinar. And we'll be more than happy to cover those. So Roman, we can go ahead.
Hello everyone, thanks for joining today. I'm glad to be here, and I hope this will be useful and interesting for you. I'll try to guide you through what is Smart MLOps is it, and how Softermii is dealing with it. So, okay, let's go ahead. As we dive into the challenges that Smart MLOps is designed to solve, let's talk about the two forces driving nearly every machine learning initiative today: data protection and cost control. Between 2020 and 2024, healthcare data volumes has tripled. That's not a typical 3x growth. With this search data comes a massive spike in storage and compute cost. We are talking about hospitals, research institutes, and startups. They suddenly dealing with petabytes of scalable infrastructure bills. At this same time, the regulatory landscape is tightening. We have like GDPR in Europe and HIPAA in the USA, and now the European Union AI Act, which classifies the most healthcare ML systems as high risk. And in the US, the FDA's 2025 draft guidance is pushing toward the real-time monitoring of ML systems in clinical settings. So what does that means for engineer teams and basically for engineers? It means that protecting patient data isn't just a legal checkbox, it's an architectural requirement. And controlling cost isn't a CFO's job, it's a part of your ML deployment pipeline. That's why CFOs and CISOs are suddenly aligned. They both want machine learning that is secure by design and cost efficient by default. That's where smart MLOps comes in. Let's go forward. So, what exactly makes an MLOps pipeline smart? It's not about running models, it's about bringing together the best practices of four domains, such as DevOps, DataOps, SecOps, and FinOps, and fusing them into a unified workflow. We start treating everything as code. Our infrastructure is defined in Terraform or Ansible, and sometimes we are using CLIs. Our compliance rules are written in policy as code, formats like Operego or something else. Even our audit evidence like data lineage or model validation is version controlled. Next, we introduce automated quality gates across the ML lifecycle. These gates inspect our data, our models, and our deployments. They can be they can flag bias, data drift, or block a model that fails compliance. And because Smart MLOps connects deeply with FinOps practices, we don't just monitor model accuracy, we also monitor resource usage, costs, and return on compute. It's a pipeline where every decision, basically technical, financial, and legal, they all are automated, observable, and enforced by code. This is what it means to go beyond traditional MLOps and a smarter, more scalable future. So let's go forward.
Dear visitors, we would like to clarify one quick question. I'm sending that via chat where you can give some response or give your thoughts. Do you have everything done manually in your machine learning pipelines? Or maybe you're planning to automate these checks? Thank you. Any volunteers?
So let me briefly make an answer for that question. For those who did, you did a great job. Now that's perfect. For those who haven't automated yet, it's better to hurry up because it is vital for your cost savings efficiency. Okay, let's make further. Now let's talk about compliance. In many ML projects, compliance is treated as a final step, something that happens once a year during an audit. But in Smart MLOps setup, compliance is continuous and built in directly into the pipeline. We use what's called compliance as code, which means our GDPR and HIPAA and fairness checks are written as policy just like code. These rules runs automatically at various pipeline stages. For example, during data ingestion, we check if every column has a lawful basic tag under GDPR. During model training, we log metrics that align the bias and fairness expectations. During deployment, we validate that the model has proper audit trails. Instead of one-time certification, we now have continuous validation. Every commit, every build, every deployment passes through a gate. And just like unit tests, these gates are color-coded. Green if everything is good and all checks passes. Red if it fails. If model fails HIPAA compliance or show drift, the pipeline halts the alert to the desired team or to the desired department. Even better, all compliance results are auto-versioned and stored as evidence. So if any auditor ever asks for proof, it's already there. It's already timestamped, traceable, and ready to share. Okay, let's move forward. Let's switch our gears for a moment and look at cost optimization, because protecting privacy is not only half of the battle. The other half is making sure you're not bringing or burning cloud doors unnecessary. Smart MLOps integrates FinOps practices directly into the lifecycle. That means we are not just tracing model accuracy or latency. We also tracking cost per experiment, cost per training cycle, and even storage usage over time. Each ML resource is tagged with metadata like business unit, owner, environment, and project. That makes it easy to answer the question like how much are we spending on dev versus production? Or which model is costing us the most of GPU time? And with centralized FinOps dashboard, we can trace spend all over the way down to individual model and pipeline stage. In short, Smart MLOps doesn't wait for the monthly AWS bill to make decision. It gives us a real-time visibility and the levers to act, pause, unused resources, downgrade instance types, or optimize storage. All that happens automatically. Okay, go ahead.
Dear audience, dear visitors, we would like to ask one more question regarding the slide just mentioned about the cost cutting levers along the life cycle. Where have you noticed the highest cost in your machine learning workflow? Is it by getting the data ready, or maybe training the models, or maybe running them in the playground or already in production? We would love to hear your thoughts in our chat. Thank you.
So while we are waiting for answers, I'd like to highlight where, based on our experience and our previous work and our previous clients, we noticed the biggest expenses. And we spotted them in the playground during training the models, or on stage environments, which basically were running all over the time. Let's go ahead. So, what kind of impact can you expect from this transformation? Let's talk about KPIs and ROI. First, we have seen up to 25% faster time to approval for ML models, simply because regulators and stakeholders trust a pipeline that enforces compliance automatically. Second, security incidents dropped by over 9%. That's because every part of system for secret to deployment is locked down with encryption or a formal infrastructure and zero trust policies. Third, we consistently achieve from 30 to 40% savings in compute and storage by dynamically scaling. These eliminating idle resources and optimizing environments. Finally, perhaps the most underrated KPI, trust from clinicians and business teams. When your system validates itself, documents itself, and scale predictably, you gain confidence from stakeholders who might not be in the main focus in the moment about YAML files and not deeply care about outcomes. Oh, sorry, but deeply care about outcomes. And here's the key insights. Privacy and savings aren't trade-offs. In smart MLOps, they're outputs. And of the same automation first architecture. Let's go ahead. Let's now take a closer look at how we scale our ML workloads. Not just for performance, but for cost control. This is where smart MLOps really shines. In most traditional ML deployments, you scale horizontally. You add more GPUs as traffic increases. That's important, but nowadays that's not enough. With smart MLOps, we take a multidimensional approach to scale. We scale horizontally to handle growing traffic. We scale vertically by selecting the optimal instance type based on model size and load. We also use scheduled scaling, so environments like staging and QA and some maybe playgrounds automatically pause during nights or weekends. This gives us the fully elastic ML infrastructure. It responds in real time to user demand, model needs, and just as important, budget boundaries. The result is up to 60% cost saving with zero compromise on performance. We are not just saving money, we're building ML system that are economically sustainable at scale. Please move forward. Here is another area where we have dramatically cut costs, our CI/CD pipelines. Many teams pay for always-on GPU runners to run model builds and test. But that's like leaving your engine running just in case you want to drive your car. Instead, our CI/CD runners are GPU enabled, but ephemeral. They only launch when needed and automatically shut down after deployment is completed. This means we pay only for the minutes we use. The runners is always secure, always isolated, and there is no idle infrastructure burning money between jobs. This isn't just a DevOps win, it's a FinOps and SecOps win too. We get stronger cost efficiency, tight security, and fast delivery, all from a single design decision. Think of it in this way. Our CI/CD pipeline is smart enough to know when to spend and when to shut down. And that's the kind of thinking every ML team needs to adopt for moving forward. Please move forward. When we talk about data privacy in machine learning, especially in healthcare, we are not just talking about encryption. We are talking about architecture choice that prevent exposure in the first place. One of our core design principle is no raw PHI in the cloud. That means patient identifiable data never leaves the hospital. Instead, we use techniques like federated learning or on-premise edge training. So the model goes to the data, not other way around. For research scenarios, we leverage differential privacy, and synthetic data generation. This lets teams share insights and train models without ever handling the real patient information. All this is reinforced with full-stack security like TLS 1.3 in transit, envelope encryption and REST, and Zero Trust IAM, which is integrated directly into our CI/CD process. And we are not just talking about encryption, we are also enforcing privacy policies at build time. For example, we can literally flip a policy flag that will block any model from being deployed if raw PHI is detected in the playground or in the payload. Privacy is not an afterwards, it's a gate in the pipeline. Please go ahead.
Dear audience, as privacy is taking an important role in our lives nowadays, we would like to clarify one more question here. Via chat, we would love to hear your thoughts. Is anyone here already experimenting with federated learning or synthetic data to protect your PHI? Thank you.
So while we're waiting for other answers, our thoughts about this is it is important to highlight that federated learning and synthetic data help to protect PHI, but by keeping real patient data private while still enabling AI model development. They reduce privacy risks, support regulatory compliance, and allow safe collaboration across institutions. Let's move forward. Here's a real-world example that shows just how powerful the smart MLOps mindset can be. Imagine training a custom speech-to-text model, maybe for a medical transcription app. If you do this on a self-hosted GPU cluster, you're looking at from $3,000 to $5,000 just for compute and storage. And if we talk about retraining, this is recurring cost. Plus, you need to maintain that infrastructure 24/7 days. We took a different road here. We used AWS transcribed custom language models. We train the training data is stored in S3 and AWS handles the model training behind the scenes. That means no GPUs, no cluster maintenance, no DevOps team babysitting the processes. We only pay per usage. The model automatically adapts to medical vocabulary, and we have seen 10x faster iterations with 100% reduction in training infrastructure cost. So instead of investing in infrastructure, we invested in result, and that's what Smart MLOps is all about. Please go ahead. Security isn't a layer we add later. In Smart MLOps, security is engineered into every layer from day one. At the infrastructure level, everything is encrypted. Redis, S3, model artifacts, even transcription data. At the access level, we use AWS Secrets Manager and SSM Parameter Store to manage all secrets and environment variables. No hard-coded credentials, no accidental leaks. CI/CD runners are also fully formal. meaning they spin up, they do their job, and they vanish. They leave no logs, no containers, no leftovers. That's zero trace execution by design. And when it comes to protected health information, PHI, our policy is clear. No raw PHI enters our infrastructure. Even transcriptions run entirely into AWS managed isolation. Security isn't something we hope for. It's something we prove with every build, every deployment, and every audit trail. We don't just secure data, we secure system, processes, and outcomes without any compromise. Please go ahead. Finally, let's talk about something every stakeholder understands. That is money. With Smart MLOps, we actively monitor and manage cloud spend in real time. We use tools like AWS Cost Explorer with usage breakdowns by project, by environment, and by resource type. We implement cost policies. For example, non-production environments automatically shut down outside business hours. Why we should run a staging GPU on Saturday night. We also configure budget alerts and enforce strict tagging across all resources. That way, every dollar is linked to a team, to a task, and to a timeline. Most importantly, our compute layer is optimized with spot instances, which gives us up to 9% cost saving compared to on-demand pricing. And thanks to fallback automation, if a spot instance fails, we recover instantly with no downtime. This isn't just about saving money, it's about building cost awareness directly into your engineering culture. Every model we train, every deployment we run is backed by a system that constantly asks, is this the best use of our resources? Okay, let's move forward. So, how do you actually implement smart MLOps? Here's a realistic 19 months roadmap broken into 3 phases. Phase 1 is all about foundations. In the first 2 months, we set up a central Git repo, CI/CD pipeline, and convert infrastructure to infrastructure as code, typically using Terraform. We also introduce basic cost tagging for all ML resources so we can track spending. In phase 2, months from 2 to 6, we lay down guardrails. This is where we integrate compliance policies using OPA and reg rules, stand up for FinOps dashboard, and introduce drift detections for both data and models. This gives us the visibility we need to scale responsibly. Finally, from months 6 to 18, we get seriously about privacy and scale. We deploy federated learning for on-prem data training, spin up synthetic data sandboxes for research, and automate regulators ready evidence bundles. They include in model cards, lineage, and attestation. At each phase, we focus on automation not just for building tools, but building systems that enforce trust, optimize cost, and scale with governments in mind. Okay, let's move
Hmm.
forward.
Dear visitors, if you are looking at this roadmap under the 18 months, and we can see the road from the foundation step to the privacy at scale. If we are looking at this roadmap, where would you place your organization today? Would it be at the foundation or maybe tackling privacy at the scale? We would like to hear your thoughts via chat. Thank you. Thank you, Svetoslav. Patrick.
So let me help or answer for that question from my side. For everyone who is at the very beginning or even hasn't started yet, it would be helpful to reconsider your strategy and prioritize this in your roadmap. Because it's really important when we're talking about your project success. Having this foundation prepared beforehand, it will be easier to cover it on a scale. Okay, let's go. Now let's look at how we maintain stability and reliability, even when we ship changes to production. We use zero-time deployment strategies like blue, green, or and rolling updates. That means we always have a working version live, and we can switch traffic instantly to a new one only after it passes health checks. Model serving endpoints are backed by auto-scaling load balancers, so traffic can shift between versions without user disruption. And each deployment runs through a built-in validation suite. If something fails, whatever it's a broken model, or slow endpoint, or a flaky instance, we don't push it to a live. Even node failures are detected automatically and replaced on the fly. So this is what production grade ML looks like. Reliable, testable, and reversible. So instead of moving fast and break things, our motto is deploy fast and no one notices it. Okay, let's deploy. Let's zoom in our real world, in our real example, a medical platform which we built for our client, 𝐃𝐢𝐬𝐜𝐸. They wanted to deploy a powerful language model, Mistral 7B, but without breaking the bank. So here is what we did. We run the model in a container environment backed by an auto-scaling group that adjusts instance type and count based on a real-time GPU load. In off hours, environments like staging automatically shut down, saving up to 76% in a running cost. CI/CD runs from GPU-based EC2 instances that spin up on demand, build and deploy in approximately 30 minutes. Then they self-destruct. We also preloaded base Docker images into a warm pool to cut down cold start time. In total, we saw over 60% savings during low traffic with 100% uptime during scale and deploy events. This is what Smart MLOps makes possible. High performance AI that's fully cost aware and operational resilient. Okay, let's go
Dear visitors, we would like to clarify one more question relying on this suit case, the real world experience that we are sharing here. And when we talk about your organizations nowadays, when scaling your machine learning workloads, how do you currently handle the cost optimization? Is anyone here using it or planning to use something like spot instances or automated scaling? We would love to hear your thoughts via chat. Thank you. Good to know, Patrick. Yep, Svetoslav, thank you.
One of great examples when your training is too costly. It's better to might switch to using pre-trained models with fine-tuning and run them on spot instances to save compute costs without sacrificing performance. That's one of possible ways to cut some costs. Of course, there are much more, but let's limit us to this one. Okay, let's go ahead. Here's another win from the same project, speech to text. Originally, 𝐃𝐢𝐬𝐜𝐸 was planning to train their own model for medical transcriptions on a GPU cluster, but we projected cost was from 3,000 to 5,000 or even more per training cycle, not including infrastructure maintenance. We instead opt for AWS transcribed custom language model. These are trained directly from S3 data with no GPU infrastructure required. We pay per usage, and AWS handles training and scaling for us. And maybe you will ask what's the results, and here they are. Approximately 90% lower training cost, zero DevOps or MLOps needed to manage this infrastructure, faster iterations, and high accuracy on medical terms like medication names or some drugs or other ways. This shows how smart MLOps isn't always about building from scratch. Sometimes it's about choosing the right service with the right boundaries. Let's go ahead. Let's summarize what Smart MLOps delivers, not just for engineers, but to the businesses. Faster time to the market, automated pipelines, cut ML delivery times by up to 25%, lower cloud costs, real-time optimization, and usage-based infrastructure, which results in from 30 to 60% of savings. Stronger compliance. That means that automated GDPR and HIPAA gates reduce audit risk and manual overhead. Security by default. Zero trust access, encrypted data flows, and formal environments reduce the threat surface, and transparent results. KPIs are traceable, pipelines are auditable, and stakeholders' trust increases with every iteration. As a result, Smart MLOps is more than tooling, it's a new way of thinking that treats ML system like enterprise software, governed, observable, cost-efficient, and built to last. Okay, let's move forward.
Thank you, Roman. We hope that you guys all found the value in learning how the machine learning operations can improve efficiency and the scalabilities in your business, especially in the healthcare domain. We would love to hear some feedback from your end if you found valuable to hear about the machine learning workflows, about cutting costs, or about protection of the sensitive patient data, what is really common and really important nowadays. So we would love to see and to hear your feedback. If you would be able to provide that via chat, feel free to do that. Thank you.
While we're collecting some feedbacks and answers, let's move forward to the next slide. To wrap up, smart MLOps isn't theoretical anymore. We have proven that it is real, it works, and it scales. By approaching ML as a product, not a prototype, we deliver a system that are cheap to run, faster to deploy, safer to operate, and easier to audit. For businesses, this unlocks ML at a predictable cost and risk. For engineers and teams and departments, it is a chance to lead a new type of infrastructure that blends software, data, governance, and finance. And for investors, it's a proof that scalable AI doesn't require an unpredictable burn rate. In total, the message is quite simple. MLOps is no longer optional. It's a bridge between innovation and impact. And that's a future. Now it's already here, and we are living in it. We are making it. So that's probably all from my end.
Thanks, Roman. Thank you guys for sharing your feedback. It's crucial for us to understand that we are doing good and it's valuable and useful information for you. So that's kind of the time being that you have found useful to your own business, maybe some expertise or workflows which could be useful to implement on your end. So now I would like to suggest to have our Q&A session where you can ask any questions that may arise during our webinar. We will be more than happy to cover those. So please go ahead and use the chat to ask these questions and we will cover it. Thank you. Thank you, Moses, for the question.
These operations not only mainly on AWS. Now we are developing and already supporting the different cloud providers like Azure, GCP, and some specifically well-made cloud providers like Lambda Labs or not OpenRouter. I forgot how it names. Let me remember one thing. Very good provider, very cheap one, especially on which we are developing a new stack which will support our future runs. Oh, RunPod. So we're not supporting only AWS, and we started from AWS and now spreading these operations all over different most popular cloud providers, even DigitalOcean, every cloud provider.
Thank you, Moses. We are waiting for another questions. We'd be happy to cover those. Maybe there is something else you would like to know, to hear from Roman. We got the question from Patrick.
Yeah. It really depends on what you have currently in your infrastructure and which services are you using. AWS and a lot of different cloud providers have good cost-efficient mechanisms like built into the panel, like reservations or how it's correctly named, um, reservations and saving plans. You can, if your infrastructure is stick to always on, you can use them. Otherwise, you can use like strategies when smaller or testing or development environments, which is needed only for working hours of your development team. You can shut down them, and automatically shut them on with some automations, which can be made probably everywhere and anytime. And of course, probably think about spot instances. They're really good one. If you were talking about some small work and small builds, like you're building the new image, and you know that the run is not going to be for the whole night or the few weeks. When we're talking about hours, it's better to use spot instances. But if we're talking about running for a training cycle for a week or for a month, it's better to have them with cost saving or some reservation.
One,
The
one more
next
question.
question. Um, Which cloud provider do I recommend for telemedicine startup? We use DigitalOcean, but it's too pricey. Uh, to be clear, DigitalOcean, one of the most cheapest one. And it really depends on your infrastructure, how tightly you are in communication with your cloud provider. If you are using a lot of different services, then some cost optimization tools. If you're using just for some place to run your code, then it depends, really depends on what you are expecting. You can rent a cheap VM on TensorDock, or you can rent a great and cheap infrastructure or some stateless and serverless or pod on such providers like Lambda Labs or RunPod. They both really cheap, and they give a lot of different ways to save money, like on-demand running, serverless, and easy manageable and easy customizable cost efficiency. So it really depends on what's your run stack and what you need from the place where you run it. Basically, this is it.
We've got some more questions by chat,
Yeah.
Roman.
Sorry. So how maybe I'm wrong in understanding the question, but the answer on how we scale our workloads when there is variance of data. First of all, we're checking the consistency of the data, and if data is consistent and the same on all endpoints, on all like pods, nodes, then the gate opens and the new server is appeared. Of course, there are a lot of different scripts running on background, which checks not only AWS service dashboard and AWS metrics. It also checks the engine metrics itself and model metrics also itself. All this combines into a lot of different status checks and approval gates, automated approval gates, which gives the way and the information depending on which we can scale. How to automate the data refresh from prod, sync from prod. It's really not stick, but trick one question, because when we're talking about medicine AI models, better to use synthetic data or some federated federated data flow, but better to use synthetic data. It's more secureable, and the real patient data never leaks to some playgrounds where anything can happen, and it's secure. If we are talking about auto updating data in production environment, then better to use not better. There is possibly two ways of use. It's always update, always sync, like automated sync, which runs every minute, every second, every some different time dimension, which pulls the new data with which LLM is working, and LLM is taking it to ML model is taking it inside of memory and working with it and updating with it. Or when you are rolling update. When you roll an update, the data automatically pulls from your data source, and it's working with new data. I hope I answered on first two questions. The second one, if batch processing done when model accuracy is impacted and drops, how to handle that? That depends on first of all, which model you choose as a base, or you trained it from the scratch, or which model you used. If we're talking about fine tuning, then yes, it's really depends on which model you choose for the scratch. If we are talking about training model from the very beginning, your own model, your own everything, it depends on how your data is good enough. If you took a great data, it's all tagged, it all exceptional and like perfect data, which can we imagine, then you need to run several iterations of training cycles and see what is needed. Maybe during some process you need to make model to hallucinate or to add some specifications or some new tasks for the train process to get model better, to understand what you really need and what you're expecting at the end. So that's basically two types of data. And if you I just answered on both types of model which you could possibly work on. Oh, I forgot. Some time ago, I faced with one problem. I was running the same model, language model, but with different engines. One was VLLM and one was Aphrodite. And basically, the difference between between these engines with the same were not huge, but it was noticeable. And in full view of the picture, it was really highlighted. The problem was that these two different engines works differently with incoming API requests, and the outcome, the model memory size and request size, which were transferred from model from engine itself to the model, was different. And some engine specifications and how engine works with model also should be mentioned here. And the last one is differences in support infrastructure, support tools, support versions of different programs, which is built in engine and built in your server. So that's basically it. It's great question. It sometimes happens, and that's why we stop playgrounds, not staging environment, it's dev environment, playgrounds, where we can experiment, see how data works, how model works, how different engines works, and they choose the best from the result, from our variance, and find the best way of training. So it's two different two different approaches of development, which are working in the same time and auto-updating and updating and helping each other.
Thank you, Roman. Imran, we would like to clarify if you received the answers for the questions. Is that all clear? Or maybe you would need to clarify something else? Okay, maybe you guys have any other questions? Please go ahead. Have a few more minutes left. I'm assuming no more questions. Thank you, Imran. Sure. Okay, then we are gonna send you this presentation via emails for you to have that. Also, we are always open for the further conversations. If you would need some other assistance, some other clarifications, you would have some other questions, you can always contact us via email or via LinkedIn or some other social media platforms, as well as we will be back with the email follow-up with all the information as we mentioned. We thank you again. Many thanks for your time for joining our webinar today. Again, we hope you found it useful. You have a great day ahead. Take care. Bye for now.
Thanks everyone for joining. Bye bye. Have a nice time.